So these last 2 hours are about source change events again. So I have a number of slides, and we'll see if we need to use the whiteboard. Anything. So a little bit of background on why we're here. So Access used the Garrett code review for a lot of our source control. As I mentioned earlier, we're sort of a little bit split between what software that goes into the devices and other software. And the stuff going into the devices uses Garrett, and we use GitHub for various other things. But we're only concerned with Garrett for the Eiffel stuff at the moment. And when we started looking into this, I don't recall if it was 2 or 3 years ago, there were 2 options for getting Garrett. Garrett events, transforming them into Eiffel. So one was the Eiffel Garrett plugin, and one was a sidecar service that was written by, I think, a summer intern at Access or similar. None of them were really great and usable out of the box. The plugin was in better shape, but it, for instance, didn't deal with direct pushes to branches. It required that everything was subject to a review. How many are familiar with Garrett at all? So like, yeah, all Ericsson people are going, but Volvo not so much. Maybe not that much.
Not our team, but I know other teams are using.
Okay. Well, I'm just so I know what language, what words I can use so that everyone understands. But there were some limitations. So the people working with this decided that the best choice was to build a new plugin. Another problem with the Ericsson plugin, by the way, was it was built for old version of Garrett, so it had to be updated quite a bit. Someone in the room is nodding, so it's yeah. And when we did this, there were a number of ambiguities and other sort of rough edges in the protocol that we found out. I mean, if you look quickly at the existing events, they look kind of good. But when you dig into the details and the corner cases, you find that they don't really match reality that well. So Sven, who worked with this, he filed this issue with a proposal for what the event should look like instead. We have discussed them at 1 or 2 other past summits and community meetings, and there have been questions and concerns, and either I or Sven have come back with sort of new iterations of this, and I hope that maybe today we can find some kind of path forward and see if this proposal is something we want to continue working on, or scrap it, or do something completely else. And I hope we have time to look into the tags question, since both NASDAQ and Ericsson and we have chosen sort of workarounds for dealing with the tags. It's a little bit strange that it was left out of the protocol from the beginning, but it was. So on to the problem with the current events then. Well, we're going to talk about this when we're looking at actual examples of scenarios with the old and the new events. But to summarize a little bit, well, this is a minor bug really, but I think the point is that this is a bug in the current events that we can't fix unless we make backwards incompatible changes. The multiplicity doesn't match the description of some of the link types. So you can't really model merges, for example, if you want to do that, and you probably do want to do that. And I think the abstraction chosen with these events isn't really good. I mean, it's the old saying that all models are wrong, but some are useful. And I think the problem with the current events is that they're definitely wrong, but they're also not as useful as I'd like them to be. And that's a somewhat philosophical view of this. How close to reality do we want to model things as well? And that's where I think we can, reasonable people may have different opinions. And this is just a small bug, but we're really, this this particular one is specific to Garrett, but if you look at a pull request based workflow, the events are made, I think we can say, in a Garrett context. So some things you can see that, oh yeah, the person writing this knew Garrett, but maybe wasn't so familiar with GitHub. So in the Garrett context, the source change created event expresses, it has a branch field, for example, and that could be, for example, master. If the event is for change that targets the master branch, but it doesn't say how to obtain that particular change or that patch set. In Garrett, that it uses a special reference in the Git repository, but that's not mentioned anywhere. So to obtain that, you have to ask Garrett, give me the reference for this particular change. Similarly, if you were using these events to model pull request-based workflows, there is no concept of like source and target repository. So I don't really know how you would even model pull requests using the old events, which is of course a rather major drawback. So I'm going to continue with a sort of overview discussion of the new event types. So there are 3 new event types. They are very different from the old ones. I'll talk about them briefly, and we'll look at concrete scenarios of different things that might happen in your source code repository and how we would model those using the old events and the new events. And we can talk about that. Okay, and I should say also about the naming, both of the events and the link types and all that. That's not at all finalized. It's the original proposal that were made in the GitHub issue. And to not introduce additional confusion, I haven't renamed it since. So consider all names to be up for discussion. So the source code change created event is very close to a Git commit. So it really doesn't contain any fields that aren't in a Git commit. So you could, well, of course you have the SHA-1, obviously. You could have authorship information if you want. If you want to have information about other aspects of the contents of the commit, how much was changed, maybe the commit message if you like, those things, that's totally fine. It doesn't have anything about repositories or branches or something, because a Git commit doesn't know in which repository it lives. The second one is source definition change request created. You might think that this is the longest event type name, but it isn't. But it's still pretty long, and I would happily change it to something shorter. And this represents a request to update a branch. So this is your pull request. This is your Garrett change. It includes information about the source and target repositories and branches. So in the Garrett case, you would have the same source and target repository, but you would have different source and target branches. So the target branch could be master, the source branch would be refs changes / something / something. If you know Garrett, you're probably familiar with that. If you don't know Garrett, you don't know what I'm talking about. And this one would link to the source code change created, sort of the commit event. So this one would basically say that a request was made to update a particular branch to this commit. And you would send new events like this every time you either upload a new patch set in Garrett or you somehow modify the pull request branch, either doing rebasing it or pushing a new commit to it. Then you get a new commit like this. We did talk briefly in one of the earlier workshops about this, whether we should have an event that represents the pull request itself. This proposal does not include that. We have instead separate events for sort of each update to the pull request. We could definitely, split this event in two and have one event saying, source definition change request defined or something, saying that a pull request has been created. But I think we can actually get by with just this event and model reality closely enough. But if we want to do such a split, I think it would be possible to introduce that later on. And the final one is source definition updated, which indicates that a particular branch has been updated to point to a new commit. So if you do a git push, this is what you get. And it'll tell you the previous state of the branch. You know, this is the SHA-1 of the previous commits. If it's a new branch, it won't contain such a link. It would link to the current or the new, what the branch should point to new now. And finally, if there are any update requests, in other words, these events that represent the request to change, it links to them as well. So if you get this, you would immediately know the old state of the branch, new state of the branch, and what's the pull request that introduced this. Any questions so far? Examples will probably help to make this more clear, but now we have at least talked a little bit about them. So let's look at the scenarios now. The first scenario is pretty simple. We have two stacked commits. In other words, two non-integrated commits that are integrated together, and they are integrated via a fast-forward update. So we have the ABC123 commit. Oh yes, and that's actually a little that makes it slightly less trivial. So the first commit in the stack gets one revision first. So we make the BCD456, but it's superseded by the CD789. And we prepare the DEF234. Can you actually read those? Yeah, I think you can read it in the back. Good. So what we want to integrate is actually this. And the BCD456 is abandoned and replaced by this one. But it's part of the same change request, so to speak. So these two belong together, and this one is on top. And what we're modeling here, I should say about notation-wise, also in the later slides, what's blue is what's the old stuff that's currently existing, and the events depicted in white are the things we are modeling in the scenario. So in this example, we don't care about this. This is pre-existing, and we are modeling what goes on here. And we update master to that commit. So that's what we want to model. That clear so far? Everyone following along? Good. There. Don't worry if you can't read this text right here. It is very small, but we won't talk that much about the actual contents of the events. The important thing really is the events and how they relate. So this is how it looks like in the old events. We have swim lanes for the different event types. So the green is the source change created, and the yellow is source change submitted. So we have source change created and a submitted that says that this one was merged to the master branch. This is the old stuff. What the user then does is push one commit. In this case, it's this example is Bulgarian, but it'll be very, very similar in a pull request based workflow. So this commit is pushed. Basically, there are no inbound links to this one, so it's essentially abandoned. This one is pushed instead. And then this one. And at some point, we decide to merge them to the master branch. So we send the source change submitted events, 2 of those, and we are done. So fairly straightforward. A few things to note here is that judging by this, there's no way to tell whether these two commits were merged in one atomic operation, or whether we first merged this one and then this one 1 minute or 1 hour later. This might not matter in some use cases. If you want to test every single commit that arrives to a branch, for example, it doesn't matter if they're submitted together or not. But if you want to react to the actual push operation itself, you have a problem because you can't separate these two from each other. You can only see that the commits were introduced, but not if it was in one single operation or not. That again might not be such a big hurdle, but we'll see later on when we look at merge scenarios. Then it becomes a bigger problem, but it's really the same fundamental problem that we're not merging. We are expressing what comes into the branch, but we're sort of losing out in the resolution of what actually goes on, which sometimes matters, sometimes not. So would the Ericsson folks agree that this is a correct model of reality of this scenario, or because this is Axis's interpretation of the spec, and you might have another interpretation?
Well, first of all, this is correct.
All right, we're good so far. Good.
Yeah.
So let's look at the new events then. So there are a few more of those. Most of the time preparing this presentation was getting everything fitting into one slide. Again, we have the old event here, or the old commit in blue. The upper swim lane is for sort of the commit events in green. In the middle, we have the yellow swim lane with sort of the change requests. And at the bottom, there we are. At the bottom, we have the branch update events in light gray. Okay, so here we have the commit, the old existing commit. It was at some point made current on a particular branch. And if we then look at the white, we see that this one was pushed, and a request to integrate this one was made here. This is what we talked about earlier about the source ref and source repo. So here, the source and target repo are the same. This is a Garrett example. But we said the target branch is master, and this is where the commit currently resides. So if you receive this event and you want to download commit for testing, this is the ref you would want to fetch. If this were GitHub, the source ref would be the name of the pull request branch, and the source repo would be in your fork instead. You would typically have a completely different URI and not just different repository names, but that's details to hash out later. Then we make a revision to this change here, and we push it to a new commit, and that results in a new request, change request. It's patch set 2 of this change, so revision 2 of the particular change. And a third commit is pushed on top. You'll note, by the way, that these two commits, this commit here supersedes this one. So it doesn't. This one does not reference this one. They have no relation in the Git world. So they have the same parent, the blue commit over here. While this one, the third commit, is the second in our stack, and it references this one. And that's in order. And then we have a second change request for this one. And when the merge finally takes place, we get a source definition update that tells us that these are the two change requests that we are merging. And this was the previous state of the branch. and this commit here is the new state of the branch. Like that. Again, this is a fast forward merge, so there are no new commits involved while performing the merge. It's just that we point to one of the existing commits that's also linked to from the change request. Still clear? Really? Good. In that case, we can.
Just one comment.
Yes.
I think you said sometime that this source definition change request created is corresponding to a change or a pull request. Now you say you send a new such event for each set to the same pull request.
Yes, I was a little bit sloppy.
Yeah.
Yeah. So it's really it's sent per patch sets for Garrett, and for pull request workflows, it's sent once every time you update the pull request branch, because in a sense that is a new. You make a new request. You're saying no, never mind that. This is a commit you're going to integrate, and you push a new commit to the PR branch. Well, now it's this one. So again, you could split the change request event in two, and have one for the pull request itself, and then have one that just expresses sort of the update. I think it's unnecessary, but it would be doable. I'm not sure it would add that much. It would definitely reduce the duplication of data in these events, but probably not necessary. Okay, so another example is updating a branch from an upstream branch. It doesn't have to be an upstream branch. It could be a feature branch or anything else, but it's really just, it's a fast forward update of a branch from some other branch. So in this case, we want to update the master branch to the current location of the upstream branch. In other words, that. So it's just a simple fast forward update for a branch. And if we look at that in the old events, you would have the existing state of the master branch here in blue. And since we're updating, the update entails including 2 new commits into this. So we send 2 new source change created and 2 new source change submitted. Here you could argue that you shouldn't have to send source change created, since there in this example there is no Garrett change connected to them, because this one is null, and we just send a source change submitted. The spec isn't really clear on what the correct behavior is, but this is how we've implemented it anyway. So we always basically have source change created and submitted. They always come in pairs. And if we look at the new events, this is what we get then. We have the blue ones, we know about them. We have the new commits, and then we just get a source definition updated. That tells us that we are updating from this state to this state right here. So this one gets pretty simple. And again, actually, there's another example of what I talked about earlier, that we can see that here it's clear that it's an atomic operation that includes both of these commits in a single push operation. That's not clear with the current events. All clear?
Can you go back to the previous slide? The previous one. The last example. What one?
This one.
This one.
Yeah.
So I'm thinking how you create this source definition change request. This one is it based on? I know how you know this the lower commit B, C, D, 4, 5, or 6 is like the previous version. Is it based on time you create the second row, or?
So when this commit this event is created.
So let's say for example, if I have a two branch, I create the commit the CDE 7, 8, 9 first, and then I get another branch, and then I commit the lower commit. So would it still be something like this kind of feature?
That's another scenario. I mean, in that case, you have two different branches, right?
Yeah, can I comment the point?
Yeah, you can do that. It'll be hard for people, but there aren't that many on Teams, and yeah.
So
Otherwise, you use a pointer on my trackband here if you want.
Yeah,
that's fine.
Sure. So I'm just thinking like how this thing get this event to get created. So I mean, if it's based on time, so if I commit this one first, then I think it would follow this kind of thing. But let's say like if this is the branch and I create this commit first, and then would it this event come before this one?
Well, in this particular scenario, the CD 7 and 9 commit is replacing BCD 456. It is sort of a new revision of that commit. You decided that, oh, BCD 456 had a bug, so I'm making CD 789 to replace it. So by definition, it always comes later.
Okay.
So that's what we're depicting.
Okay.
So
no.
So
if I thought it was two branch, and then you just want to abandon the lower one.
Right, yeah. Okay, I see. So in the Garrett case, what this represents is this is patch set 1, and this is uploaded as patch set 2 in the same change.
Okay.
In a pull request based workflow, you would create a pull request containing this commit, and then you would do a force push of that pull request branch, so it points to this commit, and then you would push this commit to be on top of the pull request branch.
Okay.
So this would basically be invisible in GitHub. Let's see. I think this is where we were. Yes. So let's continue with question. Yes.
The one you hear. So when updating from upstream branch, we create, I mean, does this commit then CDE 789? Does it already exist on the other branch then? If so, do we already have a source change created event for that one?
Yeah, it depends. Yeah, it could exist in the repository, yes.
Yeah.
So in that case, maybe this one should be blue. I mean, it depends on the circumstances.
Yeah.
And then it doesn't really affect this. With the new events, it doesn't really matter. With the old events, it's the situation gets a little bit murkier since we have the branch name is welded into this particular event. So, should you reuse that event for commits when that commit is reachable from other branches? As we have implemented it in our plugin, it's not, which we'll get to in another slide. But I don't know really what the best course of action is. But I guess that's an example of where the old events, they perhaps have a slightly too high level of abstraction because they focus on the changes that go in. So this change, when it was requested to be included in the master branch. I mean, that's a fact. But reusing this event for other, if you are representing the Git DAG later on, it becomes a little bit weird to reuse these events since they represent they represent the old state, which was true back then, but reusing it, it gets
change.
It's a new change, so why should you reuse it? I mean, if you create a new change for it onto some other branch, then it's a change.
But if you just update on the other.
Update the branch.
But if the commit is the same
use
and you're not requesting a new change, you're only doing a fast forward update of the branch here. So should you send an change created event at all?
If you push directly to the branch without passing through a change or a pull request, no, then it
No.
should be submitted event directly instead.
Okay. That's
We don't have that. We don't have that described, and we might need to alter the events to cater for that, but doesn't really make sense to have a source change create event, because you don't create a source change, you just submit something directly to the branch.
yeah. But I think that's where the existing spec isn't super clear on that particular scenario.
Especially because there are some things, some fields that are part of SC, not in SCS. But it could be that you need to send both of them, even that you're committing directly.
Yes, that's true.
But it will be very strange. But yeah.
I think, for example, that we talked about in some of the early sessions, where there is a field in SEC that would the URI of the change itself. It's not terribly well defined what that means, but we've interpreted that to mean we include a URI to Garrett's REST API with information about that commit. But if we only send a source change submitted, we lose that information.
And that there as well.
I don't think it's in source change submitted. So yeah.
That's the data.
Um, But yeah, it is totally possible that these events shouldn't actually be sent in this scenario. That's I wouldn't object to that. Okay, and now we're going to get into more of the same dilemmas. How about we could create a new branch based on an existing commit feature? This is what we have implemented in our plugin, and that's related to the fact that the SEC, the source change created, contains the branch name and various other information that's tied to the sort of the original use of the commit. So what we're doing is we're actually sending new source change created and source change submitted when we're creating a new branch, so that we can get the expected branch values. I'm not entirely sure that this is the right way of doing things, but it's Sven, who made this proposal, did a lot more thinking about this than I did, and that was a conclusion that he reached that would be necessary. And of course, doing it like this has a number of implications, because you are suddenly sending source change events that are it's the same commits that were before, and it's probably not just 3. You would potentially send, I mean, try doing this for the Linux kernel, for example. You will get something like 1.2 million events or 2 million events or whatever it is nowadays. So that's a huge problem if you, for example, trigger CI based on these events. On the other hand, if you would do it in another way, I'm not sure what that would be, because even if you would just send the source change submitted for sort of the last commit, the DF234 in this case, that would still be wrong, because source change submitted doesn't really fit the scenario. You would still run a test for DF234, even though it's no commit. So it's the same thing, same problem as running all these tests. It's just on a smaller scale. It's less of a problem. Maybe just an aberration, but it's really the same fundamental underlying problem.
Why would you need it at all?
Why would you need what?
Why would you need to notify about the new branch being created if there's no change anywhere? No new commits and nothing pushed. Why would you need to? Why would you need to run some tests on it? You already run it. Why should we run CI on such an event?
But if you have a visualization tool somewhere down the stream and you want to open commits for this specific branch, then you'll have missing commits because it doesn't have.
Commits for a branch.
Oh, well, you want to see what's in that branch and what has been done. And yeah, but maybe you want to grab some info from Eiffel chain as well in your visualization tool.
Yeah, I mean, we don't represent branches today, I would say. In that we can't have we don't today have an event saying a new branch is created.
Yeah.
So
Yeah.
trying to make it this is very, very strange to me. At all.
Yeah,
I mean, we just to admit we don't cater for that scenario.
Yeah.
Just send an event when we're creating a new branch because it's not part of protocol today.
Yep, I agree. One concrete example of where you would want to know if a new branch is created is, well, firstly, is there any other? I mean, if you want to know what is the root of a release branch, for example, if you want to do comparisons, or in general know what's the corresponding. If you have a branch point where you create a release branch and master continues, there are definitely situations where you want to know this one. Where did we branch from? Right, and not just see the commits that start appearing. For example, in a visualization, you might want to have what's sort of the baseline for this release branch or this feature branch. Where did we start? What was the current state?
I think that was discussed when the Git plugin was developed, right? When the base will be changed, how can we know the base on top of which we should eventually merge back? So to find the common ancestor of two different branches, of the master branch and the maintenance branches.
I don't think we discussed where branch really, because later on we'll discuss the changes there.
But the base link is there.
Yeah.
I don't know, but yeah.
It's probably easier to take a look at those examples so we have there. We want to discuss that again.
I can give just a use case where branches are used widely is DevOps and GitOps use cases, where you basically represent a branch as an environment. So you have like test, staging, production, same application that will be, okay, first I want to deploy in test. You set, you commit the configuration in test branch, and then you staging and production. And then you want this sandbox branches, you can do that automation. You create a new branch on your infrastructure ISE code, and that will trigger to create a new environment for you with the branch name. So those are like use cases on branches.
Yeah, very, very reasonable examples. Right. So with the new events, the only thing we need to do, since we have the commit events, they exist. So the only thing we need to do is send a source definition update and say that there is now a branch called new feature and it points to this commit. And that's all we need to do. And then we would up to the consumer to choose whether to run any tests based on this event. Okay, so now we have a little bit of a twist of the first example where we submit two stack commits through a merge commit. So we have those two commits, and in this example, there are no concurrent changes on the master branch, so the merge commit is unnecessary. It could have been a fast forward merge. So that's what we're doing. But that's really just to keep the example small. Right, yeah. So most of it, this is old news. You know, we have the source change created and the submissions. And then we get an additional source change submitted that represents the merge commit itself. And it has two previous version links because it has two parents. And this one points to the base commit, or what was earlier on master. Now, one problem with this is that since we are, see, I'm thinking this correctly here. Well, yeah, we are not really, this is ambiguous in the sense that we don't know what was, let's see, what states were there actually on the master branch. So if we imagine that we're listening, we have a consumer listening to the source change submitted events, and we get these in a sequence, and we want to trigger a test based on these, for example. That's a very reasonable scenario. We get these two submitted events, but they are not actually representing states on the master branch. CD 789 has, the master branch has never pointed to this commit. And if, go back to this example, if there had been things going on the master branch at the same time, and we would actually have a sort of a real merge, not just what's basically a fast forward merge, but with a merge commit. We had commits down here as well. This state would never exist on the master branch. Are you following along?
Yeah.
No.
I mean, I don't see why you send a submit event to say, but you don't. It never ends up in the master branch. Why do you send a submit event?
Well, it ends up in the master branch because it was included via this merge. But the master branch never looked like this necessarily. For example, let's say maybe I should have used this example to actually have parallel development. But let's say we have parallel development taking place here, and we have one commit down here, one commit down here, and then we merge those two together in this commit here. Then, you know, this would have been what the master branch looked like yesterday, and this was what the master branch looked like this morning. But this is not a state the master branch was ever in, because this commit is included via this merge over here. So if you have CI triggering on this source change submitted, it will run tests on something that's, you know, just not interesting.
But isn't it wrong to say branch master if they've
Yeah, why
never
is the
been on a
branch
master?
You don't submit it to branch master. Why is it master in that?
Oh, it is submitted to the master branch.
But you say about parallel development, the two different branches.
No, not if, well, depends. If these are two stacked commits in Garrett, I know that you're not stacking commits, which I know never ceases to amaze me that you never do that, but it doesn't really matter. You could do this. We have the same problem with, if this were just a single commit that you have as an open change in Garrett. So arguably, the branch attribute should be master, right?
If you're targeting master, yeah.
Yeah, exactly.
But you don't send a submit event unless you send submit that change as well.
Yeah, but this change is eventually submitted, but you have a submit strategy that uses merges. So in that case, the only commit, I mean, source change submitted must be sent for this commit because this particular change has no other commit. But it is introduced in the master branch via this merge commit.
I mean, the commit is just metadata. It's actually the the reference to the source change that is interesting. It's the source change that has been merged, that has been submitted.
Yes.
So that it contains a commit is, and also branch is additional metadata on the event, I would say.
Okay, sure.
So it's the interesting thing is that the source change that was created earlier, which we had a patch set for,
This one
was now submitted.
Yeah.
And if not, I mean, if there's a change with 3 different patch sets or a pull request with 3 different commits, it's just the last one that is part of the submit.
Yeah. But this is a scenario that doesn't use additional patch sets. So this is and it doesn't even have to be a stack. Again, we can just pretend that these 2 commits don't exist. You just have commit that you are introducing to a branch via a merge commit. But that commit could theoretically be 1 month old. And so it's the old commits, the old events do a good job of saying that now this commit is reachable from the master branch. It is included in whatever we're going to build. However, if you want to trigger, well-targeted CI, you would get a source change submitted for this. This event would be fresh. This event could be 1 month old, right? But if you want to trigger tests on everything that's submitted to the master branch, which is reasonable, right?
Maybe not every commit on the branch, but everything that is submitted there, yes.
Yeah, exactly.
Yeah.
Well, what's submitted? Then you would trigger on this event. Well, that's kind of bogus because this represents something that's, oh, you're saying that this, no, this commit ID must be this. The old commit ID, which is 1 month old. Unless, of course, if you, see what I said about the old events being ambiguous? Because theoretically here, you could say that, okay, never mind the merge commit here. This commit ID here should say, what's the commit ID of this commit when it actually landed on the branch? That's another interpretation or another way of modeling this. I would argue that it's not necessarily right.
Probably what your CI would go look for to find the code to run your builds and tests for. That's the commit that is interesting to put in that event, I would say.
Okay, because in that case, the commit ID here would be the same for all these 3. This one would also say BCD 345, just like the merge commit here. And this one would say BCD 345. If that's the commit on the master branch where this change is actually introduced.
Why do you need 3 different events? 3 different submitted events. It's just one submit operation.
Okay, so you're saying, okay. So we one source change submitted that would point to
The actual
multiple changes then.
Yeah, if you stack commits, so I guess that would be the way I would see it in the current event setup. Because it's probably the latest commit of that stack that you're interested to run tests on anyway. So that is what was submitted onto the master branch.
You also have a composition defined to group them.
I guess you could, but then it gets interesting because that could explain why the previous version does not allow more than one link. Because if you are not supposed to model merge commits in this manner, but rather say that you would send one source. You would send one source change submitted for the branch update, and you would link to both of these changes and have the commit ID here. That's another way of modeling it, and that would remove that problem, assuming that we can link to multiple SCCs from a single SCS. I'm not sure.
In the case of a merge commit, I'm not sure, Matthias, if it's, maybe we can have two different SCCs from different changes that get different patches, so different, different branches.
You can also link to one SCC from SS.
What is the merge, in the merge scenario? Merge, how does it handle the branches so much?
For SCS, it's probably previous versions, or at least that says in the specification. And that's the latest version that made more in case of merges.
Yeah, okay, so maybe we just agree that it's ambiguous how to model this scenario with the old events.
It's not clearly described, right?
But it's
not clearly described. How
no, definitely not.
Yeah,
No, and it can possibly be done in different ways.
Yeah, that's Norway. It's can be used in multiple ways. Yeah.
And that's actually I think one of the drawbacks of the old events, that they are, since they are quite different, they don't model reality so closely. It also means that if you are stuck with a real world scenario and you want to model it with those events, it's pretty unclear how to do that. While with the newer events that model reality more closely, it's kind of obvious how to do it. So let's look at that obviousness. There are definitely more events in this model. So here we have, again, the old events. We have the stack of 2 commits. Both of those had change request events for them. And then we update the branch. In this case, as in I think one of the earlier examples, we have 2 links to the change requests, because these are the ones that we are integrating or closing, whatever terminology you want to use. But the commit that we are actually updating the branch to is this new merge commit over here. So this is what we're sending together with the branch update. And it has 2 parents, this commit here and the old state of the master branch. So in this scenario that I mentioned earlier, where we might be merging a branch with a number of commits that could be potentially old, it's easier to see when we get this event. It's much clearer if you want to only test, the latest commits. It's simple because this is the old state and this is the new state. With this commit, we can test only this one if we want. If we want to test every single intervening commit, we can do that. But there's no, it's not ambiguous what has happened here. Right? Question, yes.
I think it would make more sense to only have one source definition change request written. Or, I mean, it's since it's a merge commit. I mean, it's one. Feels like it's one change that is done, which includes both of these.
Yeah. Well, it depends on how the yellow events. I'll say that because it's easier to say. They represent the requests. Oh, okay, yeah, okay. Well, had this been a GitHub scenario, you would only have had this one that was merged, because this one represents the latest state of the pull request branch, and that's what you're merging. So in that case, this is what you would have. This has a more Garrett-centric view where you have separate changes that are effectively dependent on each other because of the Git ancestry. And they are reviewed as two separate items. But if you submit the top one, if you select to merge the top one, it'll sort of drag in the bottom one as well. So they are reviewed as separate entities, but they could be submitted together. That's not really a thing in GitHub or GitLab, as far as I know. So that's probably why this looks strange.
Isn't it more correct to say that there are two stacked changes, two stacked Gary changes?
Oh, yes, correct, yes.
And there is no such thing as two stacked pull requests in GitHub.
Unfortunately.
Unfortunately.
Yes.
So there might be eventually. And then we need a way to show that.
Yes.
Maybe it should be modeled differently than, I mean, for Garrett and for Git, for instance.
They will be slightly different. I have made GitHub equivalents of all of these actually, but I realized that they were so similar that I didn't include it in the PowerPoint slides. But so if this had been GitHub, you would only have had this yellow event, not this one.
And that would have two links. Link to all the commits, or
this one would link to the topmost commit, and it would in turn have a previous version to the old one. So the only difference is that this commit would not exist. Otherwise, I think they would be identical.
The scenario doesn't exist. So I mean, this is not the GitHub scenario because you can't stack pull requests.
No, you can't stack pull requests, but you could have a pull request branch with multiple commits.
That's like a trigger change with multiple pepsids.
Well, they don't. That's not really the same thing. But
what's the difference from micro perspective?
Are you talking about the example where you have a branch, you open PR, and then you could have multiple commits?
Yeah. I mean that's
pushing directly.
Yeah. I mean that's what we do in the Eiffel community all the time. The only difference is that we're doing squash merges, which is a slight variation of this one, but it's the same thing. You have one pull request with multiple commits.
And I mean, the squash merges we do is very similar to the Garrett submits we do. Since we squash all patch sets into one.
Yes.
Yeah. To me, that's very much the same.
Yeah, they are very similar, yes, but there are probably some small differences. But my head is starting to spin right now, so I think we'd have to use a whiteboard to sort of get out all the little details. But I mean, there are differences between Garrett and GitHub or GitLab in this case, but they're pretty small. But the differences that are there are they are legitimate in the sense that the tools work slightly differently. So I think, I mean, if you sort of abstract those differences, you run into other problems, I think, that sometimes matter, sometimes don't matter. We mentioned squash merges, by the way, and a squash merge scenario applied here would look exactly the same, except that we wouldn't have, let's see, it's not a merge, so we would have, yes, this link wouldn't exist. So this is a new commit that introduces various changes, but it's only connected to the prior commit here. But you could still use this event to track what are the changes, or what was on the pull request branch that we squash merged. So in that sense, I think that's a fidelity that we probably won't have with the old events, but I haven't made an example of that exact scenario. But again, merge commits and squash merges are very, very similar in this case. I'm being explicit about that because in one of the earlier workshops, there had been questions about both merge commits and squash merges. So they're very similar. And I think that's what actually, yes, thanks. I don't have any more scenarios prepared. Are there any questions or concerns, or yes, Emil?
All these commit events, I mean, we talk about that the Eiffel events are mainly used for two different use cases. Either you use them to trigger something on, you trigger some following action, or you use them to notify that something has happened.
Mm.
These commit events never come by themselves, it seems. You never send them by themselves, and they, as I see it, they will never trigger, the commit events themselves will never trigger another action on the line. It's rather the other events that will trigger those actions.
Mm-hmm.
And you would, I don't really see when you would use them for traceability reasons or for rather observability reasons. Since you can ask the SCM system about all commits, the whole Git tag.
Mm-hmm.
So given that, I mean, then this is a new type of events that we're expressing, because we need to have them as placeholders due to other events somehow.
In a way, yes. It will say, if we were to remove those events, you would have to move. Yeah, I mean, I think that's a very different proposal, because you can't move the information found in the commit events into these events, because the change request events don't always exist if you're dealing with pushes straight to a branch.
It would be directly in the post-definition update event instead. Commit should be there instead, or maybe also in today's protocol.
Would you include them there? You probably could, yes.
What extra benefit does it give? Obviously, you can then ask Eiffel instead of asking Git. What does the Git tag look like?
Yeah, I think one reason is actually that how would you ask Git? There is no standard API for that, for getting that information. So this would be a way of actually unifying different source control systems for that purpose, because there is no single API for fetching that. And in some circumstances, you could have local caches of the Gits. So you speak to Git locally. That's of course faster than anything else. But that's not always practical to do, and it can be pretty expensive.
Quite surprising. I mean, if there is no API for that, hasn't people asked for it, or is it actually a valid use case to use such an API if it doesn't exist? Or why would you need that information if Git cannot provide it for you?
I mean, you can get it from Git locally. If it's a matter of, for example, generating release notes or traversing, see what has happened between two tags, for example. Currently, you would have to either use a custom API.
I mean, there's no SCM API to the SCM system, to the source code system.
Yes. Right. So if you get a tag event, however tag event might look, and you want to generate release notes, for example, or you want to figure out in general, what happened between this tag and the last one. That's a reasonable CI use case. You would either have to speak to an API, again, which may or may not exist, or you would probably have to have the Gits locally. But doing that, if you have all the information in a Git locally, it's very, very cheap. But if you don't already have it, it can be pretty expensive, especially if you don't have if you have many Gits. So these we do, I think Access OS consists of 1,200 Gits or something in total. So it gets pretty expensive to keep them locally cached to get that instant response.
For us, it's super convenient because we use the commit ID as kind of a common denominator for most things in terms of like, yeah, aggregating scan reports and et cetera, et cetera. So I don't know. Yeah, I think it's good to have it.
Yeah, I mean, you want to have the commit ID somewhere, but
Yeah. So what was the proposal then, to include it in the source definition change, or?
I don't know.
I mean, if we don't have it described as a event, I mean, we want to have it somewhere. I mean, makes sense.
Yeah, then it should of course be in one of the other events.
Yeah.
I just want to, I mean, it just feels that there's a new type of events we have sent in now with this, which we haven't before. Just want us.
Yeah, it's a correct observation that it's more sort of like it's if you have a relational database and you have many-to-many relationships and you introduce another table just to represent the relationship between those two tables. Sort of the same thing, that the probably a fancy name for that table, but that table doesn't represent an actual entity in your system. Same thing here, it doesn't actually represent an event, but we need it, or we could argue that we need it to be able to represent the things. But I totally agree that, you know, I don't know why anyone would react to this, because it doesn't really contain any actionable information. It doesn't even say, I belong to this repository. It's really just, hey, this is a SHA-1. I might be reused in many different places. But I mean, we could definitely look into, is there a way to get rid of the source code change created event and move the SHA-1 information, so to speak, into some other event, perhaps this one. But then we would need probably here and here, because obviously we need the SHA-1 before the code is merged. So we need it also in here.
For instance, we are only using the source today. We're only using the source code change created and not the submitted.
Interesting.
Yeah.
So you're not sending SES even for things that are in fact submitted to branches?
No.
Okay.
We only describe everything as like commit that.
Yeah.
And yeah.
Does that mean that you don't do any, or don't distinguish between, like, we call it pre-merge and post-merge
No.
pipelines at all? Yes, run post-merge pipelines then.
No, well, the pipelines are for the teams to set up, and we only gather the data about them. So for us, it doesn't really matter.
Yeah.
So you never feedback any results from the pipeline executions to the SCM system, for example?
No.
No.
So it's different use cases.
Yeah.
And yeah, I mean it's and for us it may be, yeah, it's like you model your needs, right? It becomes too hard to maintain and understand everything, to model like everything perfectly.
Yeah.
So yeah, that's also a thing to just have in mind, that we might not have the same needs.
Yeah.
But yeah.
No, that's something we talked about at one of the earlier sessions, that, you know, this could be interesting if you want the whole Git DAG, but if you just want more high level events, like, you know, something was merged to master, could there be a way to express that without having the whole Git DAG? And it probably is with this proposal as well, probably. I mean, you don't need to have the previous version links if you don't want to. You could just have, when you actually update a branch, it would link to whatever commit it's updated to. And this event doesn't have any outbound links. That could be one way of doing it, for example, if you want to have a more lightweight. So what do you think is
Feels like the commit or source code change created event, it should at least have some more information, at least like the repository or something, or author, or I mean, maybe, I don't know. It's because otherwise it's hard to know what's this. If you only have the commit hash and you want to look up that, maybe, or it becomes a bit unclear what it's a part of.
the problem is, the reason why it's left out is because the commit itself doesn't belong to a repository. So then you would have to send, for example, if you create the CD 789 commit in your fork, and you then create a pull request and have that commit merged to the main fork, then you would have to send a new event, even though it's representing the exact same information.
So where would that commit be created then? I mean, or that event be created if it's not a part of a project? Or
I mean, theoretically, that event could be sent when you run git commit on your machine. I'm not saying that is a good idea, but that's where the commit is created, actually. So in real life, it would probably be created the first time something is pushed, and when it's becomes known to the world.
Of course, the timestamp of that event should represent when the event occurred. And if we consider it to be when the commit actually was created, then it should be, as you say, in your local repository on your laptop or whatever.
Yeah.
Then the timestamp should be when it was committed there.
Yeah, and it's very much a matter of how closely you want to model reality. Sending it from every developer's machines is probably a bit too much reality.
But in practice, then probably still you would maybe send the event when you do the merge, and then you're doing it to a project or the request to a project.
It will probably be sent if you're doing a pull request and you're sending this event, then you need this one. So that will be the likely point where or actually before this happens, you have pushed this to your pull request branch.
Yeah.
So you would have a source definition updated event with the repository URI being your fork, and the branch being whatever you call your PR branch.
Yeah, okay. It would be hard if you only have like the commit ID to know where you're part of.
Correct, but you could you could traverse the graph to figure that out.
Yeah.
And then you could actually, then you could see that this commit was part of this fork and that fork. I don't know how useful that would actually be, but it's the point being, you can find out where the commit is available by using the links.
But so then if you want to point to something that's on a repository, a commit in a project, what would you point to? Would you point to the source definition updated then, or?
Yeah, that's an interesting question, actually.
For instance, I'm having an activity triggered, and I want to describe with the composition defined event, and I want to describe what kind of commits that are a part of that. Well, how should I?
That's a really good question. I mean, if you're lucky, you could follow, let's say it's this commit, you could follow that link backwards and get to here. But if you are less lucky, and you have, for example, this commit, you would have to traverse it in different ways. On the other hand, you want to.
Which message or which endpoint you're going to from the seed event?
From which event?
For example, the seed event comes from the fine event.
Yeah.
Which event would you link to?
Yeah, that was actually one of the questions that came up in the early sessions, although with CLM.
Maybe the one you're standing on them. So maybe then the source definition.
Exactly.
Definition
It will be this one because
Yeah.
this is what you can actually run git checkout on, so to speak. It represents a state in the source code repository. This commit is a state that we never. Well, it could have been a state in someone's fork somewhere, but the master branch went straight from here to here. So these are the sort of relevant states to check out.
But in the pre-merge scenario, where are we then? Then we haven't sent any sort of update events.
If the pre-merge scenario, you would have a change requests event, right?
Do you point to that instead?
Yeah.
CLM or whatever you have pre-merge.
Yeah, yeah. And I think that makes pretty good sense. I mean, there is a difference between having a CLM sent for a requested sort of code change, and that's. Yeah, that's true. Exactly the same. Yes. Yeah.
Okay.
So I'm thinking 1023. Should we shift over to sort of more discussing how to, if we should move forward with this, and if so, how, and then talk a little bit about tags in the end?
Could I just swap the dimensions a bit? I mean, we have been talking a bit about this is very Git focused and branch focused, and the current system is more, let's say, source change or pull request very change focused. From my perspective, when I look at this naively, I think when triggering CI activities in your pipeline, it's mostly at least related to things happening in the SCM system, some events in the SCM system rather than specific Git objects or either branch nor commits, but rather source changes and changes to those updates to those source changes. I must say, I don't even either like the current events that we have. But my main problem with the current events is that we don't have any source change updated events. So to me, the source change created event represents the source change in Garage or the pull request in GitHub, equal to in my mind when it comes to source change. And then it contains multiple patch sets or multiple commits in the GitHub case. Which would then be a source change updated event for those. And then submitted that to other. So I would like to see another way of, if there is an alternative way of expressing this, and if that's complete enough, and then we propose what pros and cons towards this would that be. It could be more. To me, at least, it would be more obvious how those events map together and how they reflect reality in the SCM system world anyway, not the reality in the Git DAG, of course, because like this is very Git centric.
Yeah, that's definitely one drawback.
Yeah. Exactly where I'm not proposing anything yet, but maybe some history lesson, of course, is that the current events are intending to be able to express not just Git, but also clear case, for example, which you have mentioned, which is not something I think we should focus on. And I think we can try to release that inheritance that we have, that baggage, and focus on Git for now, and make these events Git specific. I think that's okay. But I just want us to reflect on that if it's an alternative idea to have it more focused on the SCM system events rather than Git DAG events, which might not even be events then, because the commit is there to say it's not an event itself, because we don't even use the timestamp in the correct way for it. So in that sense, it's not really an event system.
Mm-hmm.
Can I share a use case for exactly what you are saying? Okay, I'll share on Teams and you can bring the links.
Yeah, sure.
Oh, that's a nice sketch.
Visible enough or?
No.
Yeah. No, yeah. Maybe if you can zoom in just a bit.
I can. Is it possible to zoom here? No.
You can view full screen, the view menu.
Yeah, that's true.
More options. No, you don't.
I can always do.
All right.
There we are.
Yeah, so just want to discuss a simple CI scenario just made up right now while we are discussing. So we need for example, the top case, it's like we want to run unit test on any branch whenever there is changes in any branch on the SCM system. We want to run unit test. And this green arrow is like a Eiffel event, which means the current protocol actually supports this. And then after a while, we want to create a merge request. And then in that merge request, we want to run not only unit test, but also function test. So function test, we only run on merge request, which means we need an event which will identify that now whatever is going to change is a merge request or a pull request. And that's where we want to trigger the function test. And then someone approves that merge request. And before merging it to master, I want to run a system test. So I need a trigger that not only tells me that this is a merge request, but if someone have approved this merge request as well. And then when it's a master, then any changes in master, you run another system test to make sure that that's and that one is also green because current protocol supports it. And then we have like a release job or release tag, like when you do a GitHub release, add a tag. And that will run a release job that actually release the software. So, and this is also red because the current protocol, they tag things or those things are not supported. So those red ones are something to retrospect when we are reviewing the source control protocol and brings this SCM concept of it. While the green ones are, the Git centric thing, which we already supported. Just a on the fly example. Doesn't happen.
No, I think this makes total sense.
So you say branch except master, that doesn't mean for example, you merge something to a maintenance branch or something.
Yeah, or like you don't want to run unit test and function test on a master branch. That's it. You already assume that everything has been tested. But this is just an example. You don't want to run test again and again, like same tests. So like master, you disable force push or direct push. Only merge request can be merged to master, and then you assume that everyone creates a merge request, and then in your merge request you have this definition that whenever there is a merge request, you run UTF-T, and everything needs to be passed before you merge master. So those are like SCM control of your CI.
I don't really see what SCM action do you do there in together.
Like this merge request approved or a merge request created that which specifically tells that this source stage is for a merge request, not any branch.
So the source change is great.
Yeah, source change is created here, but it has a dimension that it's not created on any particular thing, on anywhere. It's created on a merge request branch. So you need to specifically know that this branch have an open merge request. And then only you want to run certain things. A very good example of this kind of flow is when you start creating new idea or a feature, and then you have, let's say, two peers. You just create a branch and the two-person work on it. And that's this top one. But you still want that your unit test, like static analysis and everything run every time you.
It's like a private merge.
Yeah, private merge request. Private branch, but in the remote. And but you still like very few people working on it, and you still want to run some checks. Like people using Windows and Linux and often forget to change the EOF. CRLF to LF and don't put white spaces or static port analysis and those kind of things. But then after you are pretty much done, then you want to share it with
the publishers.
With more people, and then you create a merge request that, okay, I want this feature to be merged in the product. And then you start running functional tests, because then you have it.
But you always create a new merge request. That isn't just that you change status on that merge request from being a draft to being a public merge request or something.
You can
use GitLab.
Draft to public is another this SCM event. So if you add like a field with SCM event, you can do it with a custom field. That can that basically supports most of the state of the modern, like GitLab, GitHub, and those kind of things as a protocol. That will be good. But, I mean, all of this is possible today with just a custom field and based on source code.
But it's not really a new source change created. So it's like strange to call it source change created events.
Yeah, exactly. That's what
really
exactly.
And we have a similar scenario where we trigger pipelines, not when a source change is created, but when someone has reviewed it enough. So when it's approved, you say there as well. So we use that trigger today to trigger pipelines, but we don't have any events for it.
A very good example on Gerrit is verified +1 +2.
Exactly. So both that and also the code review +2. That's something we trigger events on today. Or trigger pipelines on. And actually both as well, combination.
Yeah, the combination. So those kind of.
So that's what I mean, from my perspective, we are very interested in being able to run pipelines on specific events in the SCM system, rather than things happening on some branch somewhere or some commit being created. So I'm not sure how that would be possible with these new event types.
What kind of events are you thinking of then?
How would you show that a Gerrit change has been reviewed using those events? Is that possible? Or do you need a new event for that?
No, that would be done with not sharing.
Something like the tag.
CLM events in that
I'll see
case.
them events, yeah.
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 But another option would also be to, I mean, I don't really understand the problem with the source change created and source change submitted. Another option would be to add those missing events. I mean, for the branch update them rather than like redoing the representation of a commit. Maybe.
Maybe it could be that when you attempt to introduce events, describe new things, it's hard to do that in a reasonable way and get it to fit with the old events.
Yeah.
It doesn't have to be like that, but it could be.
So, yeah, I'm not at all against refreshing our event base, say, on these events. But I want us to reflect on it if we want to have it Git based or SCM based, these new events.
Could a reasonable approach be to look into at least slightly concrete example of what you're talking about and sort of compare? It doesn't have to be detailed on this level, but sort of at least, because I'm not entirely following what you're at.
Yep.
And see if that would be possible to do with the old events. And we will most likely have to do a backwards incompatible change for them, but at least to build upon them and maybe complement with additional events rather than just clearing everything and doing it over from scratch.
Yeah, well, I think we will need to do quite drastic changes. So it might be better to change event types here and
Sure.
deprecate the old ones.
Yeah.
During some revisions. I would also like to see sequence diagrams on when these events are sent, so we can more easily see what is sent. But since I'm quite SCM focused, I would like to see what SCM operations trigger these different events, as we were talking about as well. When do we send the different committee event and the different events from what actor in the system and at what time or in what sequence? Would be valuable. Yeah, I can put it on my to-do list or our to-do list. Make a such proposal on the.
I mean, let's have some kind of draft, because I don't know exactly what you're after, so. No, but we can do that. Okay. Good. Then we have some kind of path forward, and we'll see. And if that conclusion of that discussion is that these events are the way to go, we can look into like sequence diagrams and doing more detail. Of course, this is just the fields here are just examples, so we'd have to go into greater detail and really, make the changes to the protocol, which hasn't been done. All right, well, that's a good outcome still, I think. So I have 20 minutes for some tag discussions, which I think should be quite enough. So some lighthearted ending of this day. Some people actually has no well-defined way to describe source control tags. Ericsson discovered that at some point, and you have a workaround. We discovered this a couple of years ago and asked, how does Ericsson do? And you guys have discovered it as well, and I think you asked about it on the community mailing lists or something. Yeah. So since there is no event that really fits the deal really well, and with the restrictions on what events can link to what events, this is how a tag is represented. Okay, yeah, this is of course the source change that is tagged. And we have a composition that links to the source code change. and then we have an artifact that links to the composition. I don't think you have the artifact, right? You
No.
just use a composition.
Yeah.
Yeah. So this is an example of how we do things. Ericsson probably does it a little bit differently, or I know you guys do. We have a convention for our compositions where we have a slash separated string of tokens that carry meaning. So in this case, we have sort of a type token that says that this composition represents an SCM tag. It is for Git. We're specifying a namespace, which is, well, in our case, represents our Garrett server, and then the actual source code repository as a URL encoded string. And here is the actual tag name. And in the artifact, we use this is actually standardized how it's supposed to be done, more or less at least. Yes.
You also how do you represent the remove of the tag?
We don't remove tags.
Okay.
Well, okay. So sometimes people do that, and then people like me get angry, and then it's all just water on the bridge.
Yeah.
But yeah, we don't
Yeah.
represent it, at least, no. So this is sort of why, I mean, yeah, I don't know if it's interesting to talk about the local variations between the companies, but it doesn't get much better than this anyway. So I would certainly be in favor of introducing an event that's more sane than this, and hopefully we could make it compatible with whatever we do with the source change events. It should be able to be compatible with the new ones. So is there any reason not to introduce an event that basically just points to a source change submitted and says this commit has this tag? And quite possibly you might want to include the repository information also in that, so you can actually search more easily. But is there any reason not to do that? I mean, we've been talking about it a number of times, but for some reason it's never really been done anything about it, which is a shame, because thinking of like introducing new people to Eiffel